Yes, great souls. Welcome back. We're now looking at question 4. What is it that they brought on question 4 for this question paper? So we can see, given g of x is equal to h of x equal to negative 3 over x minus 1 plus 2. This is what? This is a question on functions, right? This is a question on functions. So let's see what is it that we are going to do here. So let me insert a new page since we're starting a new question. Okay, you know those instructions that each question on a new page. They love that question on physics, I know. So, but then I'm not going to do that. Let me just do that. See, yes. Yes, I'm starting a new question on a new page. So we are now on question number 4. Okay, and you're seeing that this question 4 is a question on functions, right? So you learn the function that they're going to bring. But then for you to be prepared for the exam, just prepare yourself, everything. Do all those functions, all of them. And hopefully you'll be able to answer all the questions. So what is it that they brought here? You can see here they brought a hyperbola. This is a hyperbola. H of x is equal to negative 3 over x minus 1 plus 2. This is a hyperbola. You know that. Okay? So what is it that they're asking on this hyperbola? 4.1.1, or what are they like when you answering part exam papers, you are checking as to what are questions that you can get on hyperbolas. You see, that's one thing you're supposed to summarize when you're answering past exam papers. You're analyzing what is it that they brought on, what is it that they love to bring. You see, so now what is it that this group had to write on hyperbolas? What is it that they're asking here? Write down the equation of the asymptote of h. You see, they want you to write the equation of the asymptote of h. So 4.1.1, right? So you know that h of x is equal to, let's see, negative 3, let's see, over what? X minus 1 plus 2. Okay, your asymptote. Asymptote, the very first asymptote is this one here. We learned that. I'm not going to dwell much into that, so I'm just answering the question here. So this is what y is equal to 2, right? And then this one here, for you to get the asymptote, what you do, you solve x minus 1 equal to 0, which is x equal to, those are the asymptote that they want you to bring in that question. 4.1.2. Determine the equation of the axis of symmetry of h that has a negative gradient, right? The axis of symmetry, the equation of the axis of symmetry. So how do you determine the equation of the axis of symmetry? You know, it's a very, very easy thing. Okay. So here they're very specific, like the one that has got a negative gradient, right? So you determine the equation of the axis of symmetry, you know that you need this and that there, right? So it's simply y is equals to, you take what you have here, I get the one, the negative one, negative, negative, I take what I have here, x minus 1, and I add that value of q there, right? If they had wanted the one that is a positive asymptote, it was simply going to be y is equals to x minus 1 plus 2, right? But now the one that is a negative asymptote, you simply change the negative asymptote and yes, let's continue with our work. So what is it that we have with us here? Okay, where did I put my pen? I can't see where I put my pen. Let me pause a minute. Where did I put my pen? Where did I put my pen? Where did I put my pen? Oh, no, this cannot be. This cannot be. Wait. Okay, so as we have seen, we now have what? Y equal to negative. We're just gonna expand the negative. So y will be equal to negative x, negative number by negative 1, that is plus 1, plus 2, and this is going to make it to be negative x plus 3. Okay, so this is gradient. Okay, all right. Now moving on, sketch the graph of h showing the asymptotes and the intercept with the axis, right? So what is it that they want you to show on the what? On the sketch? They want you to show the asymptotes and they want you to show what? Sketch the graph of H, right? Showing the asymptotes and the intercept with the axis, right? So you're supposed to show the asymptotes, the intercept, and the intercept. So x-intercept and y-intercept, right? That is what you're supposed to show. So let me insert a page. As you can see, I don't have a page. So I need a page. See? I'm not sure what is happening here. Okay. This will, whatever that is happening is going to react. It's going to come back. See, this thing is moving as I'm moving the screen. Okay, let me see. Let me see something. Let me see. Then let me see now. Hey, here. Let me erase that because you see it is moving as I'm moving the screen. And it shouldn't be like that. It shouldn't be like that. I just hope it has disappeared. Otherwise, we have a problem, a serious one. Okay, yes. Yeah, it stopped. That problem is stopped. So they want us to sketch that graph, right? Let me bring this a little bit forward. So they want us to sketch the graph, and on the graph, okay, this is my what? My vertical asymptote, and then this is my horizontal asymptote, right? This is not my condition. Like sketching and drawing, there are two different things. Sketching is rough, and drawing is accurate, right? So this is my sketch here, okay. And then what did we see as our asymptotes? Our asymptote, we have them somewhere there on top. Y equal to 2 and x equal to 1. So my y is 2 and then x is 1, right? So I'm going to put my Cartesian plane somewhere here. So this is my Cartesian plane now, okay? And then 2, so I'm going to put this here now. Okay? So asymptote. Now, what is it that is left? We don't have the x-intercept and y-intercept. So let's just find x-intercept and y-intercept. But we can find y-intercept because that is the easiest, right? So let me insert a page. So for that, page break, okay? Page for that. So y-intercept. You know that here we left x equal to 0, right? So h of x is equal to what? Let's see. H of x, it's -3. So we have -3 over x minus 1, x minus 1, okay? And plus 2, okay? So you're saying we let x equal to 0. So the sum for h of 0 is equal to -3 over 0 minus 1 plus 2. So what is the answer then? The answer is -3, -1 plus 2, that is 5. So this point here is going to be 0.5. So we're having y-intercept as 0 and 5. So let me just go in there, try to put that point on the graph. 0 and 5. So 0 and 5. Okay. So this is where y is equal to 0. Okay, and this is y is equal to 2, and then 5 is going to be somewhere here. So already 5 is going to be somewhere here, right? So well, this is an asymptote. This is an asymptote. So asymptote. So like curves will be something like this. Did I do it well? No, it is not okay. It is not like this. Yeah, it is not. Wait, 0 and 5. This is it here, right? Now you can see it's not okay. This is not how the curve is supposed to be. So we take this one. Yes. So 0 and 5. So it means, as you can see, this is an asymptote. So it means my curve is gonna take this way. It's gonna go this way, right? So I gotta look. I'm doing this using a computer, so it's very I can't do a good sketch. So now you're having a pencil and rubber there. You're doing that on paper. Now I'm not doing this on paper. So now I left with x-intercept. So let's find x-intercept. So we find our y-intercept. Now we need to find x-intercept, right? And x-intercept, y is equals to 0. Y is equals to 0. So insert page break, okay? Then y is equals to 0. So we know that, okay, let me just start the phrase. X-intercept, we said y is equals to 0. What is our graph saying? Graph says -3 over x minus 1. So we have h of x equal to -3 and plus 2, right? And you know that h of x is the same as y. So this whole thing is the same as y. So we're just going to put y to be equal to 0 here. So we're going to have -3 over x minus 1 plus 2, right? And everything is equal to 0. So with it being like this, what are we going to have? We're going to have to say -3 over x minus 1. And I take this one here across minus 2, right? And then I'm taking this one here. See, I love this. I love doing this. Look at what I'm going to do here. You see, I get it. This is a fraction like this, right? This is a fraction like this. And then this is equals to a fraction as well, right? This thing is a fraction as well, right? So what am I going to do? I'm going to take this here, right? I put it here, x minus 1. What was here? Here, there was negative of its was. And then, yeah, here it's just the 1j. So that's what I'm doing there. I don't want to, but you can do that long calculation. So like some things you can just do them quick, you know. And then I have x minus 1 is equal to x is going to be -3 over -2, that is 3 over 2 plus 1. What is 3 over 2 plus 1? 3 over 2 plus 1, that is 5 over 2, right? So this is 5 over 2. So it means x-intercept, that is 5 over 2 and 0, right? So let's go where x is 5 over 2. Let's go where x is 5 over 2 in the graph. So here, our x is 5 over 2. What is 5 over 2? 2.5. So this is 1, right? Then 2.5, I expect it to be somewhere here. Just this is a sketch, remember. So the sketch is not accurate. So you see if it is not even passing there. So I'm just forcing it to pass there. So this is my 0.5 over 2 and 0. And that is it. That is what they want you to do in the exam. You know, don't spend the whole day trying to write the right thing there. No, you're not supposed to do that. What they mark is the sketch. You know, don't spend the whole day trying to write a nice graph. A nice graph is not going to give you marks. We want you to get marks, okay? We want you to get marks. We don't want you to give us nice things. We want you to get marks. So that is it with this graph. So in that way, I take it that we are somewhere, we are about to finish with this question. Yes, now looking at 4.2. 4.2, we are still on our question on functions. What are they saying here? The graph of f of x is equals to 1 over 2, x plus 5, squared minus 8. So that thing alone, it tells you that this is a parabola, right? And g of x is equals to 1 over 2, x plus 1 over 2x plus 9 over 2. That alone, it tells you that this is a linear graph. So we have a parabola in the linear graph. In the previous one, we had a hyperbola. You can see? So like these are things that you're tested on. They are testing you, actually they're examining the knowledge that you have on parabolas, they're examining the knowledge that you have on a linear graph. So that's one thing that you must take care of, okay? So yes, there you go. We have our f of x to be 1 over 2, like I've said, x plus 5 squared, right? Minus 8. And our g of x to be 1 over 2x plus 9 over 2, okay? This is what we are given. So now, they're saying here, A is the turning point of f, as you can see there, and the axis of symmetry of f intersects the x-axis at E, as you can see there, and the line G is drawn. The line G is that one that is with that equation that you've seen. And then C is the y-intercept of F and G, which is also a point of intersection. Okay. Then they are saying to us, we must write down the coordinates of A, 4.2.1. Must write down the coordinates of A. So how are we going to go about finding the coordinates of A? Let me insert a new page. You see, I'm already running a short of pages here. There you go. There you go. So 4.2.1. 4.2.1. Write down the coordinates of A. So what is A in the first place? Let's see. They told us something about A. They said something about A. They said something about A. So they are saying A is the turning point of F. So we know A to be a turning point, right? Turning point. And if you look at F, F was given in the form of, it was given as a completed square, right? In the completed square form, right? That is what they did with a F. So in the completed form, square form, they give us f of x to be equal to 5 all squared minus 8, right? We know that if we solve x plus 5 equal to 0, we're going to get -5. And then this one here is the y value, right? -8, the coordinate of A, which is -5 and -8. That's how we get the turning point in the completed square form. Remember, that's what we know. Okay, so hence we didn't have to struggle for us to get 2 marks. So that is it. 4.2.2. Okay, 4.2.2. What is it that we are asked to do? Let's see. 4.2.2. Write down the range of F. Okay, the range of F. So that is what they want us to do on 4.2.2, right? So let me see something before we attend to that question. Okay, let me insert the graph so that I'll be able to interpret it well. Page break, okay. Then the graph, okay. Oh, it is going to take the whole of this image. Fine, let me just see. What is it that is going to happen if I try to insert the whole of it? Okay, yeah, it was responding. I just became impatient, but it was responding. I want to be able to annotate so that I'll be able to show you exactly. Whoa! Look at what is it that it brought. This thing is very, very small. You can't even see. Look. Oh, these people are playing with us, man. Okay, let me see something here. But they are playing with us. We're not supposed to be like this. Okay, it's fine. It's not our fault. It's their fault. Okay, but then you see, this is the graph. Let me just try to make it to be visible so we can see this is the graph, right? And then this is the axis. So they want us to write the range, right? We know this is the turning point. What is the y value of the turning point? We found it to be -8, right? So the graph exists somewhere bigger than -8, right? So what does that mean? It exists somewhere bigger than -8. So if I put my y here, if I put my y in this way, okay, y is greater than -8. So the graph exists anywhere where y is greater than -8. So that is what they are going to simply give us the range for the graph. The range for the graph, it's where y is greater than -8. I thought I was going to get the graph, you know, as a small what? I thought I was going to get the graph only, but then they didn't give me the graph only, but it's fine. That is not going to stop us. We are unstoppable, you know. Huh? We are unstoppable. Okay, fine. Now, moving on. Moving on, we are now going to what? We are now going to the next question. Calculate the value of m and n. The value of m and n. Let's see, where do we see m and n? Okay, so the value of m and n, as you can see, What did they say about point D? Did they say anything about point D? Let me check if they did say anything about point D. Oh, I'm going far. Okay, yes, they did say something about the axis of symmetry of F, right? The axis of symmetry of F intersects the x axis at E and the line G at D. So if you look at E and A, right? If you look at the point D, E, and A here, you can see that they will have a common x value. And that x value is what? It's -5, right? From the coordinates of the turning point. That common x value is -5. Remember, we did see that it's -5. So it means we're going to say 4.2.3 at D, right? X the straight line equation. So we're going to use the fact that g of x is equals to 1/2x plus 9/2. We substitute x there to be equal to -5 plus 9/2, right? So this is going to be what? 1/2 multiplied by -5. 1/2 multiplied by -5 plus 9/2. It's 2. Yes, it is 2. So therefore, it means m is equal to -5, and then n is equal to 2. And that alone is the point D, -5 and 2, right? -5 and 2. So these are the things that you're supposed to take off. They are examining all these things, and by looking at it, like if you really know your stuff, you're not going to have a problem. Okay. All right. Now we are moving on. 4.2.4, what does it say? 4.2.4, calculate the area OCDE. Which one is that one? OCDE. O, okay? So you're saying, suppose calculate the area OCDE, right? OCDE. So what kind of a figure do we have here? OCDE. So let me just write down, let me just try to draw that figure there. You can see that one is it's a parallelogram, right? I mean, you agree with me that figure there, it's a parallelogram. This is 4.1. This is 4.1. OCDE. 4.2.4. Yes. So in 4.2.4, is it the last page? I did the last page, then I have to insert. Yes, I have to insert. Oh, I can't risk the pages, you know. I'm running out of pages, so I have to insert. 4.2.4. So we've seen the figure that they want us to calculate for. It's like this, right? I'm just trying to make things to be straight here, but it's something like this. So as you have seen, it's OCDE, right? OCDE, okay? So it's OCDE. And this thing here we said it's a parallelogram, right? It's a parallelogram. So yeah, they want us to find the area of this parallelogram, okay? So how are you going to calculate the area of this parallelogram? That's one thing that you're supposed to ask yourself. How are you going to calculate the area of the parallelogram? So do we have everything that we need? We have seen that this is near, this is -5, 2, and then this point here is -5 and 0. Then this one is just 0, 0, and then point C. Point C, we have point C. I don't think we did calculate point C. First thing first, let's find point C here. Yeah, because we can't go anywhere without having point C. We cannot go anywhere without having point C. We can't go anywhere without having point C. And it so happened that point C, they told us that this thing here is a y-intercept for the two graphs, right? Y-intercept for the two graphs. So with point C being the y-intercept for the two graphs, how are you going to go about it? How are you going to go about it? So we know that for y-intercept, we let x equal to 0, and then g of x, it's what? It's going to be g of 0 equal to 1/2 x is 0 plus 9/2, okay? And then 1/2, then 1/2 multiplied by 0 plus 9/2. This is what? This is 9/2. Okay. So therefore, the point C is going to be 0 and 9/2. 0 and 9/2. So we now have this point here. It's 0 and 9/2, right? So what is the length from here to here? From here to here, it will simply be 2 units. There's no need for us to use distance formula because it's jumping from 0 going upward. The x value is the same. And then from here to here, what is it? So we're going to take it from here, okay? And then from here to here, that's where we might want to calculate the length of this C. But we don't need it because this is a parallelogram, right? This side is parallel to this side. Here they have a parallelogram. Oh, I don't have space again. I have to find another space. So let me insert a break. So we're going to say what? Area of a parallelogram side. What are the parallel sides? Let's see. That is DE and OC, right? So DE and OC. So have some of the parallel sides, DE and OC, multiplied by the base, which is OE. Hey, yeah, OC here, and then the base is OE, as you've seen. Which one is the base? Let's confirm. See, this is the base, and then those other two sides are parallel. So those are the things that we need. So with us having that is going to have sum of what is DE? We said DE is what? DE is 2, and then OC it's 9/2 units. You can see now we are moving 0, 0 here, so this is 9/2 units. Okay, so it's going to be 2 plus 9/2, and the other side is 5. 2 plus 9/2, so that's going to be 2 plus 9/2 multiplied by OE, which you're saying it's 5 units, right? And that calculation is going to give us what? Half of 2 plus 9/2 multiplied by 5. That is 65/4, okay? 65/4. And 65/4 is the same as 16.25 square units. There you go. So the examiner here is examining the knowledge of area, you see, and functions. So this is an exam. That's what those people had to write. So it's something like that. Okay. Now we are moving to what? We are moving to 4.2.5. Okay. 4.2.5. Determine the equation of G inverse in the form of G, in the form of determine the equation of G inverse, the inverse of G in the form of Y, right? So we know the first thing that we do when it comes to inverses, we have to swap 4.2.5. We have to swap, right? So the graph of G was given to us as G of X is equals to 1/2x plus C of X is the same as Y, right? So we have Y 1/2 here plus 9/2, right? So we're saying the first thing that we do when find the inverse, we swap. So when I have here X is equals to 1/2 Y plus 9/2, right? And then now I'm solving for Y. Let's solve for Y. So I have to insert page break. Okay, let's see. So I'm gonna have what? I'm gonna transfer this side, right? To have 1/2y is equals to x minus 9/2. Okay, x minus 9/2. And then y is gonna be x 1/2. 1 divided by 1/2. That's gonna be 2. So I'm gonna have 2x minus 9. 2x minus 9 as the inverse of g of x. 2x minus 9. That is my G inverse. Remember, they said they want in the form of y. So we have 2x minus 9. So that is it with 4.2.5. And the next one, which is the last one, they are now saying to us, if h of x is equals to g inverse of x plus k is a tangent to f, right? It's a tangent to f. Determine the coordinates of the point of contact between H and F. This is a very, very interesting question. You know, they're saying if this is the tangent, it's a very, very interesting question. If this thing is the tangent to h, right? The concept of calculus is also brought here, like 4.2.6. So the examiner is bringing a lot of concept on a single question. Okay, so we have seen that. Okay, f of x was given to us as 1/2 x plus 5 squared minus 8, right? This is what they gave to us. So I'm saying here, the examiner brought a lot of things on the very same question, right? So, and now the examiner is saying to us, if this thing here is a tangent, okay? Now, with it being a tangent, we know that the gradient of a tangent, right? Since we know this is a 2x, the gradient of a tangent, which is 2, is what? The gradient of a tangent, it's equal to the first derivative of the graph, right? So you see the way in which we can't derive, so we have to first make it to be in the form that it's derivable. So 1/2 here, and then I have x plus 5, another x plus 5 to derive this. Okay, then I'm gonna have 1/2 x multiplied by x. This is x squared, right? That is x squared, and then with that being x squared, x multiplied by 5, that is going to be 5x, 5 multiplied by x, that is 5x, 5 times 5, that is 25, minus 8, okay? And this is equal to 1/2 x squared, these two here, they give us 10x, plus 25, okay? Minus 8, and this is 1/2 x squared, and this one here, 1/2 multiplied by 10, that is going to be 5x, 2 minus 8, okay? And just for the sake of finishing it off, you know, the sake of finishing it off. That's the sake of finishing it off. So what is it that you have here? You're gonna have, what is it? We're gonna have to simplify 25 minus 8. So meaning that I'm gonna have f of x is equals to 1/2 x squared, right? And this is equals to plus 5x, and 25 minus 25 over 2 minus 8, this is what? Plus 9/2, right? Now in deriving, although we're not going to, but then we have to just finish it off. So we know that the gradient of a tangent is equals to the first derivative of a parabola, right? So when you derive it, 2 multiplied by 2, it's going to be 1, which is going to be x, and then 0, right? So this one here, it's x plus 5. And already know what is the gradient of the tangent, right? From the equation that we're given as, what is it? G of x equal to 2x. What is it? The gradient for this? The gradient for this already know that is 2, right? So we already know that m here, it is 2. So we already know the gradient, that it is equal to 2, right? So x plus 5 is equal to 2. And this, what we'll be solving for here is the value of x that they will be in contact, right? 2 minus 5, which is -3, right? -3 is the value of x, that which the G inverse and f makes contact, right? So if you know the value of x, then it means we can find the value of y by substituting back into the value of into f, right? So finding the value of f of -3, 1/2 here, x is -3 minus or plus 5 minus squared, and then minus 8, you see, and this is going to be what? 1/2 -3 plus 5 squared minus 8. This is -6. So this is the point that the tangent and the G inverse, which is the tangent by that time, and f will be making contact. So this is -3 and 6. So -3 and -6. So like what is important here is like you knowing your concept, you know. I don't think those who wrote this paper would have been able to solve this if they were not remembering everything that I have been using to solve this question. So that is it with exam. Just have to know everything. So as you can see, that was the last question on question 4. So that is it with question 4. So I'll stop here for now.